There are different classification algorithms in the machine learning. As the name suggests, classification, it is the act of dividing the dependent variable into the classes and then predicting a class for the given input. So it is a category of supervised machine learning algorithm where the data needs to have the classes to start with. So the classification comes into play at any place where we need to predict an outcome from the set number of the fixed or the predefined outcomes. Because in case of the supervised learning algorithm, a label data is expected. What the input is, what the output is, it is to be provided so that when the new inputs are provided to the system, it could predict the output. So the classification uses the array of the algorithms, few of them like naive-bayes, decision tree, random forest, logistic regression, support vector machine, that is SVM, and KNN, that is K means nearest neighbors. In case of the naive-bayes, this algorithm follows the Bayes theorem, which unlike all the other algorithms in the list, which follows the probabilistic approach. In these particular algorithm, instead of jumping straight into the data, the algorithm set prior probabilities set for each of the classes for the respective target. Once the data is fed, the algorithm updates these prior probabilities to form something known as the posterior probability. In this, it is extremely useful in the cases where you need to predict whether your input belongs to either given list of classes or it does not belong to any of them. So this can be possible using the probabilistic approach, mainly because the probability thrown for all n classes will be quite low. So let's try to understand this naive-bayes algorithm through an example. So let's consider this particular example for a person who is playing golf, and depending on the factors like what the weather is outside, whether the weather is sunny or overcast or rainy, it is categorized. So first try to generate the frequencies with certain events occur in this case. So we try to find the frequencies of the person playing the golf if the weather outside is sunny, rainy, or overcast. So the available data can be seen over here for the respective data. Whether the player will play or not, or whether the person will play or not, is been mentioned. And out of that data, the frequency table is been created. So the weather is overcast, the chances or the frequency we got 4 times S. If the weather is rainy, 3 times no, 2 times S. If the weather is sunny, 2 times no, 3 times S. So the frequency table, the no frequency is 5 and S count is 9. Then the likelihood table can be tried as said over here, like can have the prior probabilities and the posterior probability. So the prior probability of likelihood. So what will be the likelihood table? So it is generated from the frequency table. The data which is gathered for the weather and as no can be identified, or the probability can be identified. So out of 5 no's, the total occurrences are 14. So 5 by 14.36. The total occurrences of S 9 by 14, that is 0.64. For the overcast weather, probability of S or no, that is 4 by 14. So output is 0.29. For rainy, 5 divided by 14. So output is 0.36. And for sunny, 5 divided by 14. So output is 0.36. So using these frequencies, we generate initial probabilities or prior probabilities. The probability of the overcast is 0.29% can be observed, while the general probability of playing is 0.64%. Because 0.64% is over here when the player is saying S irrespective of the weather condition. So that is probability is 0.64, and for the probability of overcast is 0.29. So we generate the posterior probabilities where we try to answer the questions like what would be the probability it being sunny outside and the person would play a golf. So if it is sunny outside, so the chances are playing or not playing is 0.36. Okay, so we go ahead with the probability of S for the sunny. So we'll be getting by using the Bayesian formula, probability of sunny uh, with S and probability of S with divided by probability of sunny. So here we'll get like the probability of sunny for S, that is 3 by 9 is equal to 0.33, and probability of sunny, that is 5 by 14 is 0.36, and probability of S, that is 0.64. So that prediction is possible with the help of this naive Bayes. There can also be the next learning algorithm known as decision tree. So the data can be fitted in the decision tree. So it is essentially summarized as the flowchart like tree structure where each external node denotes a test on an attribute and each branch represents the outcome of the test. So the leaf node here in this case, they contains the actual predicted labels. We start from the root of the tree and keep comparing attributes values until we reach to the leaf node. So in this particular classifier, to handle the data with the higher dimensions, the little time has been spent behind the data preparation. So a word of caution in this decision tree algorithm is that they tend to overfit the data and we prone to get the changes drastically even with the slight change in the training data. So here in this case, like uh, the outlook is uh, having three kind of weather conditions like sunny, overcast, and rain. So if the overcast is identified, the output, the final output of player to play is S. If it is sunny, so it will go ahead with the next category. It will check the humidity. If the humidity is high, so player will not play a golf. If the humidity is normal, player will play a golf. If take a look at this rainy weather outside, if it is a windy situation, so if the strong wind, so player will not play a golf. If the wind is weak, then player will play a golf. So these things like in these particular situations, whether the player will play a golf or not, that can be identified easily. So that is the decision tree over here. In case of the random forest, as its name suggests, forest is created with the number of trees included. So the random forest is the committees of the decision trees where each decision tree has been fed to subset of the attributes of the data and predicts on the basis of that subset. So the average of the votes of the all the decision trees are taken into consideration and the final answer is been given. So for example, we could see the first decision tree is giving the output as blue. The second decision tree is giving the output as blue. Third decision tree is giving the output as green. The fourth decision tree is giving the output as blue. And fifth decision tree is giving the output as red. So out of that, we could see the probability of blue is higher, or the average of the blue is higher than that of the green and red. So the random forest, which includes these 5 decision trees, will come to the solution of output as a blue. So the advantage of using the random forest is that it reduces the problem of the overfitting, which is observed in the standalone decision tree. So it will lead to much more robust and the accurate classifier. So if the decision tree is not providing the proper output, the random forest can sort out the problem associated with the decision trees. Okay.